So, nothing to do with Dr. Seuss, actually more Go-related projects. For anyone that missed it, Go is a 4,000-year-old Chinese board game. You take turns putting stones on the board and try and surround things. So, you've heard me talk before about GObject Detector, which was a library to take basically an image from like a cell phone picture of a game and transcribe it to a game record. So lately I've rewritten that in C++ so I can use it in the Android NDK. And this is a bit annoying because it turns out the Android NDK, like the C++ compiler, doesn't support exceptions with standard template library. So getting OpenCV compiled on Android required getting an entirely different development kit and all sorts of stuff. But it's pretty much working now, and I just need to do the UI on the Android side. Also, for GObject Detector, I've worked on a new feature where if you notice on a board, there are these, well, there's two things you can notice. One is the squares aren't perfectly square. There's, typically they're about 1/30th of the height wider. And then you'll also notice that there are these several start points on a board, and small differences in board dimension can cause the grid, if you just try and guess at the grid, to be very inaccurate. So now once it transforms the board up down, it tries to fit the grid to these, they're called Hoshi points, and that improves the accuracy a lot in a few cases I found. When at first I'd only tested it on my board, but when I used one from other dimensions, it was messy. So that project is pretty much wrapping up. The only things I'd like to do left is I'd like to have the feature to score a game. Like just take a picture of a game and score it. But scoring Go is actually non-trivial and either requires an AI or a user interaction. So I haven't decided entirely what I'm going to do about that yet. And it would also be nice to be able to live broadcast a game to KGS, which is a Go server. So if you were at a tournament, you could just have your cell phone watching the game and you would be able to watch the tournament game online. Sorry, I might not have given enough background for people who missed my last presentation. Is anyone horribly confused? Okay.
That could be served by putting your project in the observatory.
Tomorrow. So I'm actually talking about 3 projects today that have been kind of ongoing for a while, and now I'm kind of trying to wrap them all up to the point where I can make a release. So the next one is called GFU, which is, I call it iTunes for Go game records, and it's a GTK application. It uses an SQLite database. I mean, it's a pretty straightforward concept. You have I have a collection of 50,000 games, and it's nice to be able to index them by player, or year, or things like that. And the only thing left to really add to that is I'd like to be able to tag games and comment games without disturbing the file, and things like that. This also includes a C library for manipulating the Go file format, because there actually wasn't a good C library that wasn't 1980s style C. And then the one other thing I'd like to add that to is often you'll see a printed game record, which has a board and the stones with numbers on them. And I'd like to write a little printer, because there's no record printer that again doesn't look like it's from the 80s. It doesn't seem like anyone has really visited Go software since the 80s, actually. And then the last thing, which I've been working on since the beginning of winter break, actually, is an AI. And this is really hard, sad face, as you can see. To give you an idea, I mean, the easiest thing to compare it to would be a chess AI, where chess AIs are known to beat the best players in the world. But I would say someone who has played Go for a year, even if not seriously, should probably be able to beat any Go AI that exists. Just the large board makes it a really complex problem. So my work so far on this is first, I mean, you have to be able to efficiently represent the board. So I have a board representation, and one thing is when stones are adjacent to each other, such as the red stones, they're called connected, and I call these a block. And they have liberties, which are open spaces adjacent to them, and you have to keep track of all this efficiently as you're adding stones to the board. We use a technique called Zobrist hashing, which if anyone's familiar with computer chess, they might recognize it from that. And basically it's just a way to hash board game states, and that's one useful for a lot of AI techniques, because you don't want to revisit duplicate states. And you also, there's a rule called positional superco, which basically tries to avoid duplicate board positions, and the Zobrist hashing is used for that too. Another thing the board implementation can do is find the lines of symmetry that are present on the board to reduce the, to prevent the engine from considering symmetric moves, which happens a lot in the first 20 or 30 moves, which are the most difficult for a computer. So, I found it really difficult what to say about this because it's kind of hard to explain a Go AI without explaining Go. But I'm going to try and go high level. Basically, there are a lot of modules that try and generate candidate moves based on certain considerations you might make about the game, like expanding your territory or attacking your opponent or something like that. And the moves are evaluated by what's called a Monte Carlo evaluator, which is pretty much the state-of-the-art in computer Go right now, which is unfortunate because it's kind of a dumb idea actually. It takes a move and then it randomly plays out, say, 10,000 games until they're done, just randomly plays, and sees which ones you win more often. And that's actually pretty much the best anyone can do at computer Go right now.
Rob, so when you have, how many modules are there, the possible moves at any given state?
Oh, well, I have a lot planned. I'll get to that shortly. So far, I only have a few that I've been actively working on, because the Monte Carlo evaluator itself is capable of playing, especially on a reduced size board. Actually, these kind of, on a 9x9 Go board, for example, these just kind of randomly play out game techniques can be very powerful. And these playouts can be light or heavy. And a light playout is just literally random, and a heavy playout is when the moves are analyzed by the various modules. So this is the sort of working part. What I'm working on now is there's this whole, we need this for a bunch of things. Basically, you just need to have a standard format for storing a pattern on a board, independent of translation and rotation and stuff, and then be able to match against it quickly. And there are a few reasons you need to do this. And so the first one is this is one of the modules. Prosecchi means the opening of the game. And for example, this move was found after about, I would say, 700 years of these two moves being played. And then this response was found about 100 years later and became popular. So in the opening, there's a lot of moves that a lot of thought has gone into, and you're not going to find those again just by performing a search. I mean, people have been playing it for 4,000 years, so you have to tap into the knowledge. So using my aforementioned giant collection of professional games, I'm extracting an opening database, and that's typically relevant for around the first 50 moves or so. And then there's another thing called Joseki, which refers to sort of isolated positions. And this is just a position that comes up a lot. And basically the idea is, as far as anyone has ever been able to find, white can play B or A, or suffer a terrible law. But I mean, the specific reasoning behind this, you can't just show a few moves to say this. Like, it might not be obvious for 100 moves or something. So this is again something you can't approach with a Monte Carlo type approach. So there has to be some knowledge. So they're also probably also going to extract the Joseki database from pro games, and there are some existing Joseki databases. Another thing here too is the Monte Carlo AI is purely tactical. It just it plays moves with no understanding of them. It plays them because it finds that they have a high likelihood of winning. But here, the Joseki database can be annotated with saying if white needs to favor this side, white plays B. White wants to favor that side, white plays A. And then another important part of patterns is when I mentioned blocks, which were groups of connected stones. You also, even though these red stones aren't touching, you call them connected because there's no way for black to prevent them from becoming a block. But also there are weaknesses in a play at any of these can change that and require a response. So I don't know. I'm probably going to have to look at other Go AIs and how they handle this, because pretty much everyone uses a database approach for just what kind of shapes are connected and what aren't. And then what I'm hoping to do that's a little different than typical Go AIs is also encode sort of proverbial knowledge. Like in this position, black might like to play in the middle. This is kind of exotic, but black might like to play in the middle of these stones. But any human player would know it's just like one of the first things you're taught, that if you want to attack here first, attack here, you can attack here first to build power. Yes, this is what I say on the side. So, I mean, this is useless if you don't understand Go, I guess. But black would play these stones first, exchanging them for the blue ones before attacking. And basically the idea is there would be, say, an invasion module which would find that move in the middle and suggest it and say that will invade your opponent's territory. And then the invasion module will query a thickness module and say, are there any plays that I can use to build power before I invade? And then once these modules have found these plays that seem to be strategically justified, they're analyzed in Monte Carlo with heavier playouts and for longer. I'm sorry if that was kind of whirlwind. It's a difficult topic, but any
Rob,
questions?
what happens if you restrict it instead of usual 19 by 19? What happens if the game is played over 9 by 9 or 11 by 11?
Oh, well, on 9 by 9 it just uses the Monte Carlo evaluation, and it does pretty well. It doesn't do its best, like it could do better, but 9 by 9 isn't really difficult, and I don't think, like none of the opening databases or anything like that are relevant for the small boards. Actually, small boards, computers are almost better than humans at this point. But it's not really, the small board isn't really interesting because I don't know, I really find the whole Monte Carlo approach just kind of sad. Like it's just it's not a very interesting approach. So I'm trying to model it based on how more like a human would play the game. And I mean, what a human would say here is, I would like to invade that, but first I'd like to make it a little harder for white. Anything?
So you said there are other Go AIs. So
Yeah,
did you start this from scratch, or why did you?
Yeah. Well, so I mean, there are lots, but no one really knows, how to do it. Everyone has their different approaches. A lot so far has been focused on improving the Monte Carlo method to either run faster or reduce the number of playouts required and things like that. The specific part I'm trying to approach with mine is to try and encode a lot of the, I call it proverbial knowledge that humans know about the game, because it is a thing. Like if you look at game records from, say, 1,500 years ago or something, you would think, wow, like, these players aren't very good, because there's been a lot of time to develop thought about the game, and you just can't brute force that out.
You may want to try to set up a collaboration or something, because I mean the problem this hard, there's no matter how smart one person is, you're not going to solve it right by yourself.
Yeah.
If you have all these other people that have written their own, if you say, hey guys, let's work together, and everyone can write their own module that's focused on a particular thing, that seems to make more sense. Like.
Yeah, I mean, I'm familiar with the existing ones. I spent a good month or two reading papers and going through the sources of all the existing ones, and I think most of them right now are trying to approach it fundamentally differently. Like all the interest right now is just in improving the Monte Carlo evaluation, because that's the only thing that's really had much success so far, but actually no one has tried to make a more knowledge-based engine. So I mean, I might look at collaborating later, especially soon. I'd like to have it playing online constantly, which would hopefully attract their interest. But I mean, for now I'm still trying to add a lot of ideas. Like I feel like something like this eventually, for example, has to be written in C, because it does demand very high performance. But for now I've been writing most of it in Python, just because it's kind of exploring the ideas. Yeah?
So I know a lot of the chess AIs will kind of use records from old games, like maybe as long as you follow a record of like, say, a Bobby Fischer game,
Yeah.
the computer will do that too and follow what Bobby Fischer did.
Yeah.
And then, so it can kind of get that. It doesn't need to use the Monte Carlo, at least for the first, the opening, the first like 5 or 6 moves of chess.
So,
Does this kind of like do that?
yeah, that's what this part is for. And I have there's a large collection of games you can find online, especially if you're willing to look at strong amateur games instead of just professional games. But it branches very quickly, and so I mean it does help a lot, because the Monte Carlo method is completely useless in the opening. Like on an empty board, it just tends to play randomly without guidance from the opening.
And can it show you which record it's using? So you can kind of see where maybe the other person went with after it branches.
I guess. I haven't thought about that. I mean, it probably wouldn't try and follow, won't try and follow one record diligently, because then it would become kind of boring to play. But in a situation, it might query the database for like everywhere that someone played.
Right, I know, because in some chess, like sometimes I'll play a specific opening, and it'll show you, a few different examples from different players of where they went after the first 8 moves, and so you can look at what they did, as maybe like a guideline of what might be a better idea.
Yeah.
I know that kind of helps with your review.
Yeah, that might be useful for this because actually one of my main reasons for